This section is about scalars, vectors and trajectories. So you walk for 10 miles. How far away are you from your starting point? Well, it depends on if you walked in a straight line or not. If you did, then you will be 10 miles away from your starting point. However, if you walked around in a big circle, then you'll be right back at your starting point, 0 miles away. And if you walked on some other sort of path or trajectory, you'll be somewhere between 0 and 10 miles from your starting point. This is a classic example of the difference between distance and displacement, the difference between scalars and vectors. Let's suppose that you walked around in a big circle with a circumference of 10 miles. Your position at any time can be calculated as a point on this circle. Your displacement is the vector to this position from your starting point, and your distance is the proportion of the circle that you've moved around. Let's assume that our walking speed is 2.5 miles per hour, and look at where we are after 1, 2, 3, and 4 hours. After 1 hour, we've travelled a distance of 2.5 miles, a quarter of the way around the circle. However, our displacement is only 2.25 miles in the direction northeast. After 2 hours, we've travelled a distance of 5 miles, halfway around our circle. Our displacement is 3.18 miles northwards. After 3 hours, we've travelled 7.5 miles, 3/4 of the way round our circle. Now our displacement has decreased back to 2.25 miles and is in the direction northwest. Finally, after 4 hours, we've travelled all the way around the circle. Our distance is 10 miles, but our displacement is 0. We have another chance to visualise the difference between scalars and vectors if we think about the difference between our speed and our velocity. We've said that our walking speed is always 2.5 miles per hour. What about our velocity? Well, it's also 2.5 miles per hour, but it has a direction as well, and this direction is the direction that we're going in. So at 1 hour, our velocity is 2.5 miles per hour north. At 2 hours, it's 2.5 miles per hour west. At 3 hours, it's 2.5 miles per hour south. And at 4 hours, it's 2.5 miles per hour east. These velocities are all instantaneous velocities. Another thing we can do is calculate our average velocity. This is given by our final displacement minus our initial displacement divided by the time taken. After 1 hour, our average velocity is 2.25 miles per hour northeast. After 2 hours, it's 1.5 miles per hour north. After 3 hours, it's 0.75 miles per hour northwest. And after 4 hours, it's 0. A similar thing happens with acceleration. Our speed doesn't change, so we can say that our scalar version of acceleration is 0. But we're going around in a circle, so we must be accelerating towards the centre of the circle, and this instantaneous acceleration is given by the radius times the angular velocity squared. Similarly, our average acceleration is given by our final velocity minus our initial velocity divided by the time taken, so that it changes like this after 1, 2, 3, and 4 hours. So, what have we learnt from walking around in a big circle? Out in the real three-dimensional world, the direction you walk in matters as much as the distance you travel. That is, we need to work in terms of vectors rather than scalars. This was most evident when we considered velocities and accelerations. Our speed was constant and our scalar acceleration was 0. However, our velocity and acceleration were always changing in direction. And that's how, when working in more than one dimension, we can walk at a constant speed but end up back where we started. Using vectors instead of scalars gives you a complete description of your trajectory.